Hello everyone, my name is Chris Dustin. I'm a professor in the physics department at Merrimack College. I'm also the director of the Mendel Observatory, which is our on-campus observatory. That's where I am right now. This is our main telescope up here. I just want to make a real short video to talk a little bit about the interesting astronomical event which is happening next week on December 21st, the conjunction between Jupiter and Saturn, tell you how to observe it, what you're actually seeing, and talk about how we understand how those kind of events happen in modern astronomy. So let's get into it. Okay, so this is what the sky looks like at the day that I'm doing this recording, December 14th, at about 5:15 in the evening. The program I'm using to show you the sky is called Stellarium. It's a great free and open source piece of software. It runs on desktops. It runs on lots of mobile devices. I really recommend it if you want to look at things in the sky and know what you're looking at. So those two bright objects right there, this bright one right here and the little one right there, that's Jupiter and Saturn. We can show that by turning on the labels. You can see that that's Jupiter and Saturn. So the first thing that you want to know about when you're observing this phenomenon is you have to do it right at sunset. So this is 5:15, the sun is just beginning to set in the southwest. And if I go even an hour earlier at 4:15, really it's not dim enough. You still really, unless you know exactly where to look, you really aren't going to be able to see Jupiter and Saturn together. So that's why I'm doing this at 5:15. And then for about an hour after that, you'll be able to see the two planets. An hour later, they're getting close to the horizon. Then at 7, they're basically gone. So you have to look right at sunset or right after. So you can see they're very close together. Planets move around the sky. That's what the word planet means. It means wandering stars. The ancient astronomers knew this, and you can see that if I go backwards in time, Jupiter and Saturn get further apart. This is about a week ago, 2 weeks ago, and you can see they are further apart in the past. And if I go forwards back to today, right here, they are going to get closer and closer until they're almost overlapping. And then you can't even see the difference between them on the 21st. Now, on the 21st, they're going to be about 1/10 of a degree apart. That's about 1/5 of the full moon. So most people's eyes are going to be sensitive enough to see them as two separate dots, but they are going to be extraordinarily close. And so what I want to do is try to understand how that is happening and why that is happening. And in particular, the fact that they look very close in the sky does not mean that the two planets actually are very close. Ancient astronomers who didn't know how the planets moved thought that this was a very important event, maybe portenting something to happen in the future or associating other kind of spiritual notions with this kind of event. But in fact, it just is a result of the celestial mechanics of how the planets orbit the sun. And so now what I'm going to do is I'm going to jump out to a different part of Stellarium, which will show you how the planets orbit the sun and how we get these kinds of events and how we understand them. Okay, so now I'm using Stellarium to view the entire solar system sort of from above. So like if we could go really far away from the sun, above the plane of the solar system, we would look down and this is what we would see. Of course, we wouldn't see the orbits of the planets. Stellarium is putting them in there for our benefit. But you can see the major planets, Neptune, Uranus, Saturn, and Jupiter. And if we zoom in, we can see the minor planets as well, Mercury, Venus, Earth, and Mars. So the most important thing here is to notice that the sun, although the sun looks very large, it is not actually that large in the sky. Stellarium is designed to show us exactly what it would really look like if we were able to do this, zooming above the planet of the solar system thing. So it's so extraordinarily bright that it looks very large. That's what Stellarium is telling us by showing us this image. But we can see that these orbits are all relatively correct in shape and size. Mercury is a little elongated. It's not quite a circle. That's because Mercury's orbit is not quite a circle, and the other planets are correspondingly correct in shape and size. Okay, so to see the conjunction, we want to get Jupiter and Saturn on the same screen as the Earth. Okay, that looks good. So right now, the screen is showing us December 21st, and we can see the conjunction happening. So what happens during a conjunction is we're on the Earth, we look out to Jupiter, we see Jupiter, and then behind it, we see Saturn. So to us, Jupiter and Saturn are along the same line of sight. So they appear to be very close to each other in the sky when they are not actually close to each other at all. They are thousands, millions really, of miles apart. If you think of the Earth-Sun distance as being a huge distance in human terms, Jupiter and Saturn are still separated by many times the distance between the Earth and the Sun. To get a sense of how these things happen, we can tell Stellarium to move forward in time, and we can observe how the planets orbit the sun. And we can see that the Earth is moving relatively fast around the Sun, Mars is moving relatively slower than the Earth, Jupiter is moving even slower, and Saturn is moving even slower than that. So it's these relative motions that create the situation that allows the planets to appear to be lined up. And so if I catch it right, I think that I can show you another opposition right there. Yeah, so right about there, maybe back a little bit. You can see that the Earth, Mars, and Jupiter are all lined up like this. So on this day in August of 2024, if I look out to Mars, I'm going to see Jupiter behind it. That's a different conjunction. That's a conjunction between the planets Jupiter and Mars, but it's the same basic idea. You look at Mars, and behind it, you see this planet Jupiter. They're going to appear to be very close to each other, but they are not in reality going to be physically close to each other. They just appear that way. So that's what we're seeing in the Jupiter and Saturn case. Okay, so here we are back looking at, on the 21st, what the conjunction is going to look like from Earth looking out at the sky. And now I want to talk a little bit about what I'm looking forward to and what I hope I'm going to be able to show you guys on the 21st. So the really exciting aspect of this for me is going to be that if you have access to a telescope like we do, you're going to be able to see both of these objects, Jupiter and Saturn, in the same eyepiece. Like through the same eyepiece, you're going to be able to observe both planets at the same time. And that's a very rare event. I don't think I've ever been able to do that with any two planets. So I'm really looking forward to that. So let me try to show you what that might look like by zooming in on Stellarium. So you can see the planets are really extremely close to each other. An eyepiece, you know, when looking through a telescope, you will probably see about this. This is 0.2 degrees of the total size of the eyepiece. And you can see first that the planets don't look like dots anymore. They look like real planets. You'll be able to see the sizes of the planets through the eyepiece. And also you can see something really cool, which is some of the moons of both planets. So you can see the 4 Galilean moons. These are the 4 moons that Galileo discovered, the 4 brightest moons. You can see them through any small telescope, these 4 moons of Jupiter. You're also going to be able to see Saturn's rings, which are really one of the most beautiful sights that you can see in the entire universe. And also you're going to be able to see some of Saturn's moons, specifically the brightest moon of Saturn, Titan. So Saturn's moons are quite a lot dimmer than Jupiter's moons because they are so much further away from the sun. The moons only glow for the same reason that our moon glows. It reflects light from the sun. So the moons that are very far away are going to be much dimmer because they're reflecting much less light. So I'm hoping to be able to show this to you streaming on my YouTube channel on the 21st. Of course, there could be clouds or any number of other technical things. I was able to get a picture of what this looked like last week. So last week they were separated by quite a bit more. So let's say it was around the 9th or the 10th that I took the picture. And you can see that there's Jupiter now and there's Saturn up there. So they're now separated. This was a few days ago. They're separated by quite a large distance, and they are no longer like real objects. They just look like points on the screen, right? Well, I got a picture using our telescope that has a very wide field of view. So this is normally what we observe with that kind of telescope, wider fields of view. And so I just want to show you what that picture actually looks like, and that's right here. So what's cool about this is, so this is through an eyepiece. This was me looking at both Jupiter and Saturn at the same time, and I got a picture with my cell phone. The lower one is Saturn. You can actually see it's elongated. You can't quite make out the rings, but you can see that there is some reason why that planet is not a single dot, and that's because the rings are there. Jupiter is on top, that's the brighter one, and what's really cool is you can make out a couple, maybe even 3 moons. Now, I don't know which moons those are. The brightest ones are Ganymede and Callisto. I don't know what the third one could possibly be. But anyway, we're starting to be able to see both of these objects in the same eyepiece through a telescope. I'm really excited by that. So hopefully I'll get the live stream going, and I'll be able to show you guys what these 2 planets look like through the same eyepiece, through a telescope, and it's going to be really, really interesting to sort of experience that and mark that in an astronomical event. So that's what I'm hoping for, but, you know, depends on weather, depends on clouds. All we can do is cross our fingers. Okay, I hope that's given you a little bit of information about the conjunction, what we're looking at, and how we understand this from a scientific perspective. But also there's an aspect which is just like, this is a cool thing that doesn't happen very often. It's rare, once every 20 years, but this is a super rare event. The planets are going to be exceptionally close in the sky, so I encourage everyone to go out and start observing tonight as soon as you can, so you can observe the planets getting closer and closer until they get as close as they get on the 21st and then start to drift apart from each other. Best of luck observing. I hope you can see it. Thanks for watching, and I will see you next time.